All right, so here's the nearest neighbor method. So suppose a sales director who lives in city A is required to fly to regional offices in 10 other cities and then return home to city A. Well, that's going to give us 11 minus 1 factorial, or 3,628,800 possible Hamilton circuits, which is a list that's way out of my, I'm not going to try that many. And so what do you think of this option? Or we're going to start in city A, and then from there, we're going to fly to the city with airport who's cheapest, and then fly to the next one that's the next cheapest, and so on. And from the last of the 10 cities, we're going to just fly home to city A. And if we do that, we're basically going from the smallest edge to the smallest edge to the smallest edge. This is called the nearest neighbor method. Okay. Now this doesn't always give us the optimal solution, but it's going to be a lot easier to figure out something close because that's a lot of different possibilities here with that number of cities we have to fly to. Okay. So this method basically says uh, we can approximate it using the following steps. Model the problem with a complete weighted graph. Okay, well, we can do that. That's not a problem. Usually they give it to us or we can draw it easy. Identify the vertex that serves as a starting point. That's not a problem. From the starting point, choose the edge with the smallest weight. Then move along this edge to the second vertex. Okay, so we'll get to the second vertex. Now, if there's more than one edge with the smallest weight, choose one of them. It doesn't matter. So if there's two of them that say are 4, go with one of them. It doesn't matter which one. Okay. And then from that second vertex, choose the next edge with the smallest weight that does not lead to a vertex that's already visited. And so then we'll go to the third vertex after that, again, choosing the smallest one. Now we continue building the circuit one vertex at a time, moving along the edge with the smallest weight until all vertices are visited. And again, we don't want to go back to any vertex that we've already visited because that's going to be kind of a waste. And so to be able to do this, we keep going to different vertices. And then at the last vertex, we return to our starting point. All right, so here is a problem. And we're supposed to find the optimal solution using the nearest neighbor method. And we want to start at A. All right. So we're going to begin at vertex A and we want to find out what the cheapest way is. So we look here. From A, we can go 14, 24, 18, or 13. Well, it looks to me like 13 is our smallest. So that's going to be number 1. So we're going to go here. We're going to follow this path. And now we're at B. Now at B, we can go over to E at 100, down to D at 13, or down to C at 5. Well, guess what? 5 is the smallest. So that's going to be our next one. All right, from C, well, we can go over to D for 12, up to E for 85, or up back to A. Well, we don't want to start the A because we haven't got these two over here yet. So that one really is not an option. So it's one of these two, 85 or 12. Well, 12 looks to be the best one. So that looks like our third point. So now we're going to go over here. Now here, well, that one takes us back here. So we're not going to use that one. This one takes us back here. So we're not going to use that one. But guess what? We have to use that one. And now that's not the smallest, but those other take us to vertex or vertices that we've already been to. And so we have to take the 154. Okay. So that means that's our step 4. So now we have to go back up here. We're up to step 4. And now we need to get back to A. So we're not going to go back to C. So that's out of the case. We're not going to go back to B. That's out of the case. So the only option here is to go up here, and that's going to be our 5th step. Okay. And so we're basically going from A to B to C to D to E to A. And if we want to know what our weight is, which is what they're asking us, we're going to have 13 plus 5 plus 12 plus 154 plus 14, and that's going to give us 198 as our total weight. And this would be our circuit that we would follow for the Hamilton circuit. Okay, again, only hitting each vertex one time. All right, so that finishes this section, and hopefully that will help you.